Dear guests, professors, students, good afternoon. I'm Zhong Liang Wang, and I come from Natural Kaohsiung University of Science and Technology, Department of Marine Biotechnology. Today, I'm to show one of our lab's projects, the production optimization of Ganoderma mycelium pellets using Taguchi method. Reishi mushroom, his scientific name is Ganoderma, and is kind of high-value medicinal and edible fungus. Also contain the bioactivity, the tryptophanes, polysaccharide, and polyphenols. In traditional of cultivation method are using mushroom grow beds cultivation into fruiting body, which have long cultivation time and high cost. Also, you need to fall in the tree to making picking material. But now we have the new cultivation method, the liquid culture, by the shaking flask. So the point of this project is the mycelium pellet from the liquid culture. First, we cut the edge of the granite reishi for solid cultivation first. After solid culture to grow with the white mycelium, and then inoculate to the liquid culture medium in a flask for liquid culture, and culture for 7 days to form the mycelium pellet with the orbital shaker. Until now, there are many applications about mycelium pellets, like biofacilization of algae recycle or absorption of pollutant. And the factors that affect the formation and growth conditions can be roughly divided into physical and chemical factors, and there are many factors here. So our research is to find out the optimal cultivation formula for mycelium pellets, because I found that when using PDB culture to mycelium pellets in a lab, and then it will become like a group, we need to form the spherical about to the mycelium pellet. So we use the Taguchi method, which can reduce time, cost, and find the condition faster. Like this project, we have the 4 factors and the 3 different levels, and which means we need the 81 of the flask to do this experiment. But if we using the Taguchi method and to design the orthogonal array, and then we only just use 9 of the flask to do this experiment and find out the best condition. And our standard cultivation, we using Ganoderma tropical to solid culture and waiting for white mycelium to grow up and then to inoculate into the liquid culture for 7 days in orbital shaker at 25 degrees Celsius with 130 rpm, and then to become the mycelium pellet. The Taguchi method. First, you need to choose the factors and levels. Like this project, we chose the 4 different factors and each different 3 concentrates to be the levels. And to design of orthogonal array, we designed the 9 different experiments to do the Taguchi method. And then to do the experiment. The end of the experiment, we will to analyze the data to determine the optimal levels. We use this formula, the Taguchi method formula, to analyze the data. Certification. If correct, yes, and then we will to have the optimal condition here. And if no, we will to reset the Taguchi method and to do that again, and then to find out the optimal condition here. And this is the image analysis. We will to set up the photograph equipment by ourselves, and then we use the image analysis to analyze the pellet amount and pellet size. Contribution of control factors. And the pellets amount and pellets biomass is the yolk, the height is the contribution here. And the size is the dextrose, the contribution the highest. We need to find out the best formula, so we will choose the high ratio to be the best formula. The A, pellets amount. We will choose the level 3, level 3, level 2, level 3, which means is the potato is the level 3 is the best formula, and the dextrose is level 3, and the YE is the level 2, and yolk is level 3. And like B, the size is the level 1, level 2, level 3, and level 3. We can be sorted out down this table. And here is the best formula here, which means we need to count to the height is the pellets amount, and then we use this formula. The height is biomass, we use this formula. The big size, we use this formula to cultivation. So here is the best formula here. And then we find out the yolk is the high contribution in the whole experiment. So we do the next experiment is add the different concentrates of the yolk. And then you can see the amount of the mycelium pellets will increase when increase the yolk concentrate. And when you add to the 0.5 will be the balance. So you can see the yolk can help to increase the mycelium pellets, while also can help to increase the mycelium biomass very clearly. And you can see when we 0% and to the 1%, it will to increase about the mycelium pellet. And next is the effect of yolk on different fungus. And you can see here is have the 3 different fungus here. And we have 2 different experiments. And one is we don't add any yolk. And one is we add the 0.25% yolk. And very clearly you can see when we add the yolk and the mycelium pellet amount were to increase in this experiment. Conclusion. In this research, we're using the Taguchi method to find the best condition to increase the mycelium pellet amount. And then we find this the best formula can increase the mycelium pellet. And after subsequent experiment, and this is proof that yolk can help increase the amount of the pellet, and this is the most influential factor for the culture of mycelium pellets. And thank you for your time for listening.